We've got a reasonably full house, Melissa. I can't see the status anymore.
Yes.
Everyone's sort of trickled in. Okay,
Yeah.
great. Okay, well, welcome everybody to the EarthScope Geodetic Imaging meeting. This is a meeting that many of you are familiar with and has been going on for quite a while. The meeting has its origins as the originally was the WinSAR business lunch and has been run in person at the American Geophysical Union every year for quite a while. Um, this year, due to some changes in how the National Science Foundation supports things like meals and catering expenses, we were struggling to run this as an in-person meeting in New Orleans. So we made the decision, Lindsey and I made the decision to kind of run this as a virtual meeting this year. So it buys us some time till next year to see if we can bring it back in person. I think the good news is that this makes this meeting actually more inclusive with more participation because only so many people attend AGU every year and have time to make it to a lunch. So uh, that's the kind of, oops, there you go. So I sent out a brief agenda to everybody when you received the Zoom invite. Um, this is a rapid fire meeting of roughly 5-minute presentations. So we'll have about 60 minutes of presentations and then some time for discussion. And the idea here is these are just updates from the various groups that are doing things related to INSAR, both software and the satellite systems, space agencies, and some of the work going on at EarthScope. Um, this is a Zoom webinar, so there's a Q&A function. So if you could use the Q&A to ask questions, people are welcome to answer those questions on the fly. But as I said, we also have some time at the end for bigger discussions, although not every presenter is going to stick around because people have schedules that are challenging and they have other commitments. So thanks to everybody who's presenting, and thanks to Melissa Weber for organizing and sort of operating the Zoom webinar in the background. So Nuno, without any further ado, would you like to go ahead? I'll stop sharing.
Can you hear me?
Yes.
Oh, If I start, will share. Do you see my screen?
Yes, I
Is it
do.
okay? Okay. So good. So good morning or good afternoon, everyone. I'm Nuno Miranda. I'm the Sentinel-1 mission manager. I will present you a brief mission status of Sentinel-1, focusing on what will happen the next year, because I just have a 5-minute slot, and after that slot, I will have to rush because I have other commitments. So if you have any questions, please feel free to ask. I will probably have to answer them offline, but do not hesitate. Okay, so let's go. Right. So this is a slide that I used to show in order to start my presentation that gives a brief overview of the timeline that we are running on with Sentinel-1 mission. Basically, after the failure of the B unit back in December 21, the mission was relying only on the A unit, and I used to say that the mission was in a critical state at that moment. The A unit is in space since 11 years, much more than the 7.5 years for which it was planned nominally. And it's now showing a lot of signs of degradation, especially with the propulsion system. And this is important because it has some connection with what we're going to do this year. So, of course, since the launch of CND back in 2024 and 25, the sky is now brighter. We are looking for a full replenishment of the constellation by mid this year, with the intention, and we'll see that later, to operate Sentinel-1A until the end of the OCR of Sentinel-1D. So we'll see that later. And to dispose Sentinel-1A right after, as we did for S1B. So after that, the mission will rely entirely on the CND units, and that will provide together continuity of measurement at C-band for the next decade, bridging up to the Sentinel-1 next generation that we are currently preparing, that will take over back in the mid of the 30s. In the meantime, we are preparing 2 other missions, which are Rosen, the L-band companion of Sentinel-1, that has just passed the CDR and for which we are planning for launch beginning 2030, and the Harmony mission, which is a bistatic companion of Sentinel-1D this time. Okay. So it's a busy time that we have in front of us. So what's happening? The big news, of course, is Sentinel-1D that was launched back in December last year. And you can see here a nice image of the plume of Ariane 6 at the time of the launch. The LEOP has been completed in 3 days, record time for a Sentinel-1 unit. And the first images were taken at the very end of the LEOP. They were unveiled, I think, several weeks after they had been taken because our DG wanted to keep them for the ESA Ministerial Council. So after the LEOP, we started what we call the orbit acquisition phase because we wanted to place Sentinel-1D in a specific node, one day apart Sentinel-1C. So this took us several weeks to get there. We are there since mid-December. We stopped everything during the Christmas break, and we started actively the commissioning phase on the 6th of January, starting all the classical tasks in terms of pointing determination, antenna verification, and then we'll run through all the radiometric, geometric, interferometric, and parametric calibrations. The commissioning will run until April, and everything is good at the moment. So here you see basically this image shows basically the it's 3 images actually. It's all the Sentinel-1A, Sentinel-1 units that have taken the same shot over the Pinellas Glacier around the time of the launch of Sentinel-1D. So what you can see in the background is basically the Sentinel-1A extra wide SWAT, and in the middle of this image, you show it now, you have the Sentinel-1D image that has been taken right after the LEOP. So we were extremely happy to see that, to see this, because we don't know, we still don't know where we are in terms of calibration, but with this images like this, we know that we are not far away from our target. And actually, the first results that we just had yesterday are confirming that. So far so good, and we hope to have the commissioning completed in time for April. So now a lot of people is wondering about what will happen next, and what will happen next is basically what we call the Sentinel-1D take-up duty. So over the last months, we have been thinking and putting in place several scenarios for this take-up duty. And there are 2 scenarios that will move forward. The first one is the natural one, where basically Sentinel-1D takes over Sentinel-1A. But this poses several issues. The first is that we have to do 2 hops, so it takes longer. And the second is that for doing that, we have to use the propulsion system of Sentinel-1A in a way that we don't want to use it. So we put in place a second approach, basically, which is called the fast track. It's basically keeping Sentinel-1A unit where it is and moving Sentinel-1C in phase opposition with Sentinel-1D. So it's faster. It's a one-slide transfer. It leaves the A units where it is, and it just takes several weeks of operations. So the disadvantage is that we have new orbital nodes, but basically we've been discussing that internally at ESA with our Copernicus services, with our quality working group, and we believe that this don't pose any problem for any of the application, and this is the option we'll move forward with in the future. So we'll move forward with this solution according to a plan that is shown here in this slide. I won't discuss the details of this plan. You will be able to look at it offline. The main message is that we'll move forward gradually. Starting mid-April, after or close to the end of the Sentinel-1D IOCR, the 3 satellites, Sentinel-1C and D, will be operating in parallel for roughly 10 weeks, and this will give the time for anyone to smoothly integrate Sentinel-1D in their pipeline. At that moment, Sentinel-1D will have an observation scenario that will be a subset of Sentinel-1C. So we'll be collecting here a massive data set with data 1 day apart. After these 10 weeks, we'll do the node transfer of Sentinel-1C. The mission will rely on Sentinel-1A and D. And then after that, so this will take 2 weeks. After that, basically, we'll switch off Sentinel-1A, and the mission will rely on Sentinel-1D and Sentinel-1C. So what will happen with Sentinel-1A? We will place it in what we call IOSB, in orbit standby, pending for its disposal. That will happen, basically, we hope within this year. So I think that I have exceeded my time. So I was having just the last slide to present the characteristics of the satellites that we are preparing on with Sentinel-1 first generation, Rosel, and NextGen. I won't enter in the detail of them because of time. So I'll stop right here. So if you have questions, I will be able to take one question and then I'll take the others offline.
Great. Thank you very much, Nuno. That's super helpful, and we appreciate you taking the time to do this. I know you've got another commitment, so feel free to run off. There's actually no questions at the moment in the Q&A, but we'll keep track of questions. If anything comes along, I'll send them to you so you can answer offline.
Thank you very much. Have a nice meeting. I'll look at the replay offline, and then all the best for the meeting and for this new year. Thanks.
Thank you very much. Paul, you are up next.
Yes. Let's see. Says send request, replace current share. There we go. Okay, desktop. Which desktop? I think it's this desktop. Good. All right, let's get going. I have 5 minutes, right? So,
Ish.
yeah.
Oh, looks like we may actually have your other, yes.
Yeah.
Oh, there you go. That's good.
Okay,
Thanks,
so very quickly, NISAR is in orbit as of July 30th, 2025, around 6 p.m. in India. This was an animation before launch, what we've been showing for about 10 years. This was the actual launch, looks kind of similar. We achieved everything that we hoped for the launch, launched right into the orbit that we planned for. I don't have time to show this video, but I'm going to just show you that we had cameras on board, and this is the reflector as it's being deployed. Pretty cool. And this is an image of the satellite taken by an optical system in orbit about 100 kilometers away. So there is evidence that we actually are in orbit, and we did achieve what we wanted to achieve. So I'm just going to give you a brief status. As you have seen for 10 years, this is the plan that we put in place to image the Earth, all the ice and land-covered surfaces every 12 days on ascending and descending. We started executing this plan fully in mid-October. We are now on the 8th cycle of this kind of coverage, and I'm very pleased to say that for the last 2.5 months, this plan's been executed very smoothly, very minimal data loss, no hiccups really on the radar or the flight system or the ground system. Every now and then we'll lose a pass. We've had to do some collision avoidance maneuvers, that kind of thing, but generally it's just kind of unbelievable how well things have been going so far, knock on wood. We've processed all of these data effectively in an operational sense and proved out that we can keep up with this kind of processing load. We've ingested already 450 terabytes of data and produced 3 petabytes of products. Pretty good news overall. These are the products that we've been telling you about for the last 10 years. They are all being produced on an operational basis. Due to a number of issues that I'm going to talk about, most, if not all of these products will have to be reprocessed because of various factors I'll talk about. Nonetheless, they're all generally looking great. The data quality is great. The radar is performing as it's designed, and we just need to fix a bunch of issues with the processing and one particular issue with the flight hardware to get it so that we're comfortable giving the data out to you. Once we release the data, and I'll talk about the release schedule coming up, they'll all be at the NASA Alaska Satellite Facility, DAC, or whatever they end up calling it later this year, and you'll hear about that from Wade later. The S-band data and the L-band data associated with that S-band data, mostly over India and certain Antarctica and certain other targets, those will be available at the ISRO equivalent site called Bunidi, and their schedule is loosely tied to our schedule. So from a geodetic imaging point of view, what we mostly care about is INSAR. We have had lots of issues with the data coming into this, and now we are pretty confident. Heresh Fattahi, who's leading the team developing the processing software, pretty confident that we understand just about every feature we see in the data. Here's a very long interferogram that was produced from the operational system showing fringes that are likely, very likely due to ionosphere in the mid-latitudes and in the high latitudes, so the low latitudes and the high latitudes, the mid-latitudes, very nice fringes that you might expect. The ionospheric estimating software part looks very much like ionosphere, and once corrected, we see a very nice, smooth interferogram. No real artifacts from the radar across the swath as we thought we might see. Really very nice. This is the coherence all along. This banding here is, of course, due to rubber sheeting issues with the ionospheric phase. So really good. We have this split spectrum methodology where we have two frequency bands we call frequency A and B separated to give us the best possible estimate. It's looking really good. Our baselines are almost always less than 200 meters, which is super fantastic for repeat pass interferometry. We've been really extremely successful at keeping in the diamond, except when we have to avoid collisions. We do happen to be at the peak of solar activity right now. Not a great time to be trying to validate an interferometric radar because phase anomalies could either be ionosphere or other things, but we think we've got a handle on all the problems associated with the radar. So here's the product status. Literally, we had an image about an hour after the radar was turned on. So we were pretty confident that the processing was going to go really well. However, by processing this 450 terabytes of data over the last 8 cycles, we have identified a number of issues, both with the products, the data coming off the radar, understanding of it, and we actually did discover one pretty subtle hardware timing issue in one of the digital units on board that really does impact the ionospheric correction. And we have not quite identified a full, robust solution for it because of the beamforming that's on board. There's blending of data. We need to somehow deconvolve that. So we're working on that pretty hard. It's one reason why we haven't released the data to you all yet. We don't want anybody getting confused. But these data, once we figure out the fix, we will reprocess them and regenerate them sometime in the future. So here is the product release plan. In the end of January this year, we're pretty confident now that we can release some sample products that will be good for you, not confuse you. Interferometric, a whole suite of products for solid earth, geodetic imaging, cryo, and ecosystem sites. That will be a very limited set, maybe 5 or 6 scenes. In the end of February, we're working hard to release a very large set of products that will be useful for you testing your science workflows with mini time series, examining the quality of the data yourself. I know many of you might be writing proposals for an upcoming NISAR Roses call. These data should be available to you for writing your proposals. They will not be fully radiometrically calibrated for this community. It probably doesn't matter much from a phase perspective. I think they'll be comparable to every other data set you've ever looked at, especially because the ionosphere is so active and that's a dominant source. Even after the ionosphere correction, there's a combination of residual ionosphere and tropo. In April, if all goes well, we hope to finish all of the corrections for the software, get the provisional calibration done, and start releasing all the forward processed data from that point onward to the public as we have talked about over the years. Data is required, and within a few days, the data will show up at the DAC. And then sometime in the future, hopefully around May or June, we will reprocess the historical data up to that point. There may be yet another reprocessing campaign for better calibration sometime later. But again, I'm not sure that's going to affect this community too much. So I'll stop there. Any questions?
Great. Thank you, Paul. No questions in the Q&A, but people can add them. Paul, if you're willing to hang out, just anything, feel free to go ahead and answer. Heresh, you are next.
All right. Let me see if I can share. Yes, looks like I do see the slides. And is this visible as is? Am I sharing the i3 update slides?
Yes.
Okay. Good morning, everybody.
I think you need to hit the allow there on your
All
screen.
right.
Yeah, there you go.
Okay. Good morning. My name is Heresh Fattahi from the NISAR project, leading the algorithm development team. But I'm going to talk about the ICE updates, and I narrowed it down to ICE 3. I know the community extensively has used ICE 2, and it has become a community package, really. The current focus for us has been for a few years now developing ICE 3, and the main driver has been NISAR. So the current status for ICE 3 is that the development is fully migrated to public GitHub. I know many of you in the community were wondering that if we claim it's open source software, the development should be fully open as well to align with NASA's open science strategy. Believe me, it was not easy, but we are very happy that is done finally, and the development is fully on public. So there is no more mirroring from the internal GitHub's at JPL and mirroring to the public. Everything that you see, everything we do on ICE3 part is public. And with NISAR now on orbit, that is very important. I do believe that will be one way of the communication with the community, those who want to know more about the processor for NISAR. We have made progress on the documentation. There is a live website now as part of the GitHub, so you can check out the documentation. The goal is to make significant more improvement for the documentation, but right now there is clear instructions for installation, different ways from source or from Conda and all that. The current focus, as I said, is NISAR, and based on what you saw from Paul, we are in the middle of the CalVal, calibration and validation. So that's definitely the driver for whatever we are doing on ICE3 part. The workflows are getting really mature. As Paul showed, we have the software has been used to generate 3 petabytes of products already, so it is getting really mature. It has been in production, experiencing several cycles of NISAR data. And remember that it has been in production for Opera project as well, that my colleagues are going to talk about Opera shortly. But the co-register SLC from Sentinel-1, which is over North America, and radiometric terrain corrected Sentinel-1 backscatter, ICE3 has been in production for a long time now, a few years already. So it is supporting multiple projects. Of course, NISAR, Opera are the big ones, but we have smaller projects and smaller softwares that are used for different purposes, including, for example, Compass, Sentinel-1 Reader, Map project, OpenSAR Lab, if that still is going on. And I'm sure in the commercial world, people are using the software these days. Very short on the future plans. It is very normal as NISAR is live now, and as the products are coming out as a result of the CalVal activities, there will be improvement as needed, especially when the products are out. I'm sure people will have, the scientists, you guys will have feedbacks, and that is very normal that part of our job will be to improve the workflows. And that's open science, open source exercise. It's going to be very exciting. We have, so the project on the NASA side is committed to process only L-band data. However, we are very excited that NISAR is dual frequency and has acquisitions over certain regions, including India, part of Western US, as Paul showed in the observation plan. A lot of you may be interested to also look at the SR products. One way is to get the products from ISRO's colleagues that will be also available, but also provide enabling this community to be able to process SR data is also, it's funded project now for us. So we are working on that to develop the processor for SR as well, basically adapting what we have for SR. We are definitely planning on developing tutorials and training materials for ICE3. We are open to support future SAR missions, either from JPL or outside. Definitely, we are interested. ICE3 team is interested. And we are hoping to add support for non-NISAR sensors, but that is not funded. ICE3 resources, this is my last slide. It's public GitHub. Whatever we have, you have, so it's there. Please, actually, I'm very happy that we merged one of the community PRs, which is the first one, of course, a previous JPLer, but who's familiar with the software, but still, he's not at JPL, and Scott Stanowitz had a PR, and that marks the first community contribution to ICE3. But it's open out there. People can contribute if they can, either to the software or to the documentation. The documentation is live, and the discussion forums is there for you if you want to provide feedbacks, questions, and all that. So it's a software for the community, and we hope to work with all of you to maintain it and improve it. Any question for me?
Great. Thank you, Heresh. There's one question in the Q&A, which seems like one you could answer by just typing, and everybody will see your answer.
All right.
So in the interest of time, maybe we move on to Yunling. You're next, and then just for Wade, you're on deck, or Wade and Franz, you're on deck. It looks good. If you just hit your present button, you should be good to go, Yunling.
Can you see my presentation?
Yeah, but it's not in presentation mode. So if you wanted to hit the presenter view and make the slides bigger.
Here you go.
Perfect. Looks good.
Yeah.
Thank you.
Okay. So, good morning. I'm going to talk about just a quick overview, update on UAVSAR and the future of AirSAR-NG, the next generation airborne SAR. So just a brief recap. In 2025, we had 5 key campaigns in addition to a number of smaller acquisitions. So one of them is the snow retrieval experiment that was led by Shadi. And we collected a very dense time series data, snow data over Idaho and Lake Tahoe. And they're going to look at L-band sensitivity of snow. So this was like 6 acquisitions over 10 days or something like that. So very dense time series. And so the next one is the groundwater recharge experiment, requested by Stanford University. So we collected 9 observations over from February to October, I believe. And so we wanted to see the groundwater recharge in the foothills of the Sierra Nevada. And so the data is, all these data are available on the UAVSAR website. So it's, and at ASF, it's not just for the PI use. Everybody can use this data set to study the groundwater recharge, as well as any other experiments data we collect. And then the next one is a landslide in Southern California in this a coastline community of Rancho Palos Verdes. And it's a slow-moving landslide, but because of all the rain we've been getting in the fall of 2020, in 2023, we had a lot of rain, and that seeped into the ground, and the land was actually shifting at 10 centimeters per week. So the city of Palos Verdes, Rancho Palos Verdes, they were using ground GPS stations to monitor, to do monthly updates of the ground deformation. So it's really nice to be able to use airborne SAR and hopefully NISAR as well. But when it's moving, well, NISAR might work. Sentinel-1 didn't work too well because it was moving so fast. And so we are able to provide this information to the city to help them manage, how to deal with the houses near these landslide zones and utilities. So that was Al Handwerker was the leader. And then one of the disaster response work, the quick rapid response work we did was we were asked by the NASA Disasters Rapid Response Program Office to support the flooding in Texas Hill Country near Austin, Texas. And so we went there very quickly, like within a day and a half, we deployed to Texas and we were able to map the flooding. So of course it was a flash flood. So the water in the main channel of the river was already gone, but there were still a lot of flooded areas in nearby community. So in this case, we were experimenting with rapid response polarimetric SAR products, and we use machine learning to do the flood detection and classify it into different flood conditions. So this was very useful to help the local community to plan for flood response. So this year, 2026 is going to be a very busy year now that NISAR is launched. We will be supporting, for a big chunk of our time, we'll be supporting NISAR as well as biomass post-launch CalVal. So this is really exciting. And in addition, we're also doing some science research, such as the above Arctic campaign and the other RNA studies like landslide and wildfire. So we start flying in March, and we will be doing the San Andreas Fault monitoring 24 days apart to cross-calibrate with NISAR. And then after that, we will be doing twice a year observation to compare to NISAR deformation measurements. So that's solid Earth calibration. And we are also doing a number of other calibration validation along the Gulf Coast and the Everglades in Florida. And the big one is I guess I'll go to the next slide because I have the details of this TROPISAR 2026 campaign will be based out of Peru. And then there's a piggyback campaign in Panama. So the calibration site is mostly in Peru, and although there is one site in Colombia. So we'll be looking at inundation extent. So we'll be imaging this flooded forest 6 times over a 3-week period to look at water level change and compare that to NISAR data. And we are also going to observe above ground biomass and also soil moisture. All these sites we have selected are sites that are instrumented and well studied, so we will have ground validation and to help NISAR validation. And we're also using this, we've been talking to the biomass mission team, to also cross-calibrate with biomass data. So one of the things that people are very interested is to see the saturation of biomass sensitivity from L band to P band. So L band supposedly saturates in 100 megagrams per acre hectare or less, and then P band is supposed to saturate much higher level, So we want to see that transition, the relative sensitivity between the two L-band frequencies. And so we will be underflying both NISAR and biomass mission. And right now we're funded to fly L-band, and we're looking for funding to also deploy P-band radar in July. So that's going to be a big campaign. We're also looking at tropical glacier in Peru, so that's going to be an opportunistic calibration site for NISAR as well. So next gen, we're actively building the next generation airborne radar. This is going to have digital beamforming capability and also support multi-static radar observation. So the airplane is being modified as we speak, and the airplane modification will be done this summer. And then after that, the L-band radar is near completion, the instrument development, and we will be installing the L-band radar on the airplane probably in September, October timeframe and start flight testing. And after that, we will also transition the P-band radar to this G4 platform. So the idea is to have both L and P-band on the same G4 aircraft. So whenever we fly, we will have both frequencies. And if funding is available, we're also planning to put the Ka-band single pass interferometer on the G4 platform. But right now, we're not funded to do that. So that's all I have. Any questions? Thank you.
Great. Thank you, Yunling. There's 2 questions in the Q&A, which hopefully you can answer by typing so people can see those responses.
Okay.
And then we'll transfer to Wade and Franz.
Thank you.
Thank you.
First, there. Can you hear me and see my screen?
We can. Yep. At least yep. Looks good.
Okay, let's minimize that so I can see the screen. All right. Hi, I'm Wade Albright. I'm the director of ASF. I'll give you a brief status of what's been going on this past year. So as you heard from Paul, NISAR was launched very successfully. Kudos to JPL and ISRO. It deployed flawlessly. We're very excited to get the data. We've been actively ingesting the data here at ASF, and it will be available in all the normal avenues through ASF, through Vertex, the APIs, ASF Search, Earth Access, and Earth Data Search. And so you may have heard that there have been funding challenges at NASA, and so we don't know what services will be available yet. We know we will be working on subsetting and mosaicing, but we're working with ESDIS and NASA Earth Science to get as many services for NISAR as possible. We have the operator intermediate products available now, CSLCs and RTCs, going all the way back to 2016 now. They're also on the NASA GIS server, Aegis. You can see the QR codes there. There's product information for the RTC products on the right. The new thing this year for Opera was the displacement portal. This is a visualization time series within Vertex. You can click several points within the map on Vertex and see transects and the displacement on them. It's been a close collaboration with the Opera team, which has been fantastic. And it is at the minimum viable product right now. So there are more features coming for this displacement portal. If there are things you'd like to see, please contact us and let us know. But we're continuing to optimize and improve this interface. Another thing that was new this year is multi-burst INSAR for Sentinel-1. So we've had burst-based INSAR products for a little while now. This year we implemented multi-burst INSAR. So you can create an interferogram from multiple bursts as long as they're in the same orbit path. They don't have to be from the same SLC. You can see in the example here on screen, on the left, you have the full SLC interferogram. In the middle, you have a single burst. And on the right, you have multiple bursts put together. And so this is available just in the programmatic modes using the APIs or the SDK, but we will make it available soon using Vertex as well. And so there's a QR code for the story map that gives you all the information about it. But it's a really nice product that allows you to use and access less data than you would with the full SLC. New this year, NASA worked with ESA to support, get an agreement in place to support the new Sentinel missions we're launching. So we have S1A and S1C supported at ASF right now through NASA's agreement. S1D, as you heard from Nuno, was launched successfully. When that comes online, NASA has an agreement in place with ESA now to always support 2 of the Sentinel missions at a time. So we expect to be supporting S1C and S1D very shortly. And that should be flawless in the same interfaces and same manners you access all the other Sentinels at ASF. We've been working on getting ALOS 2 in our ingest pipeline. That has been available now for most of the year. We have about 5 petabytes of the ALOS 2 ScanSAR mirror in place. I believe there's several petabytes yet to go, so we continue to transfer data from JAXA for this. But currently it's just available as through Vertex as the data itself. If there are other services you would like to be applied that we currently offer for Sentinel for ALOS 2, please let us know. The way that the budget is going these days, we need requests from the community to sell the reasons and to convince them that these are necessary for the community. And so if you want to see baseline visualizations or RTC or INSAR on-demand processing, please contact us or NASA Earth Science and let us know. But here's the data that we have for ALOS 2 in the regions we have. The orange shaded boxes, we have data from August 2014 to March 2025. For the non-shaded boxes, data from August 2014 to March of 2023. And we're continuing to pull data as we get them, but these are the working with the community, these are the regions that were identified as high priority. Okay, and that's all I have. If you have any questions or feedback for us, you can reach out to me directly at my email on the screen or to ASF's user support office at the email on the screen or our website.
Great. Thank you, Wade. There looks like there is a question that I think Franz just answered. So, and there's definitely some good conversations going on in the Q&A, so make sure you're paying attention to that, everybody. Next is Stephen Chen from JPL talking about Opera, and the last in our kind of block of NASA presentations.
Okay. Let's see. Can everyone see my screen?
Yes, looks great.
Okay, great. My name is Stephen Chen, Opera project scientist. For those who do not know what Opera is all about, to put this in a very simple sentence, Opera is a project that pulls in multiple streams of a satellite data, optical, radar, to create a couple of data products to satisfy the satellite needs of a federal agency. So specifically, we produce surface water extent, surface disturbance, surface displacement, as well as vertical land motion. Now, I know in the past, I think about 2024, we presented a similar presentation at the same meeting at AGU. So what I'm going to talk about is mainly the new update since then. So if you look at the right-hand side of the slides, these are the new updates that I'm going to talk about. First, we are going to produce a radar-based, a Sentinel-1 SAR-based disturbance product in March 2026, 2 months from now. So that SAR disturbance product will be used to track vegetation loss using radar technology. So it will be different from HLS, the optical one. So these radar products will be able to see, will be able to track vegetation changes, land cover changes, day and night, regardless of the cloud cover condition. And also, we just secure continual operation funding that allows the project to increase the size of the constellation of the satellite. So now we can incorporate Landsat 9 as well as Sentinel-1C and Sentinel-1D in our product stream. So making not just more satellite sources to be available, but also longer data record. Now, next up is the historical surface displacement data release. We already finished the 2016 to 2024 surface displacement data based on Sentinel-1 data. The data is now on ASF deck, available also on the visualization portal that I will talk about shortly. And two also additional developments, both Opera radiometric terrain corrected product, RTC, as well as surface displacement recently just matched the international CIOS ALD compliance standards. So now it signifies the significance that the products are now certified to be analysis ready and user-friendly in user-friendly format. So I will talk about more in my next slides. So because of the audience of this meeting, I will mainly focus on surface displacement and vertical land motion, as well as two intermediate products as input to surface displacement and vertical land motion. So I will start off with the RTC and then CSLC and then surface displacement and then VLM. So all products except VLM have a 30-meter posting, and with a temporal sampling subweekly and weekly up to weekly and 12-day cadence. So all products can be discoverable from the NASA Earth data search on the right-hand side of the slide. So start with RTC. RTC stands for Radiometric Terrain Corrected Product. So we use Sentinel-1 data to generate RTC, basically a sub-backscatter corrected for topographic variation. So continuous operation funding allows us to extend the production to at least 2027, and our ability to welcome Sentinel-1C and Sentinel-1D later this year. It is also the only, as far as I know, as the only operational NASA radar product on NASA WorldView. So NASA WorldView provides a very intuitive user interface for user to go there to point and click and look at the entire RTC data product at 30-meter resolution. I believe it is also the highest, other than the optical product, the highest, the satellite data product with the highest posting on NASA WorldView right now. So here I just screen capture a portion of a river in Congo, within Congolian forest. And you can see a lot of a fine feature of the river's pathway. But it's very amazing that user can go to NASA WorldView and look at wherever they're interested in, because it is a near global product. And it is, as I said, the first NASA radar products certified to have met CIOS compliance. This is the RTC in action. Grace also in the audience who taught a workshop back in sometime last year, on a workshop to illustrate how to use the RTC to do lava flow mapping in a region, Snake River Plain in Idaho. So we are just 1 email away at the end of this slide, just 1 email away for us to engage with you on a further application of this product with the community. So starting from this slide, I will transition Opera product from a near global basis to a North America geographical coverage. So starting with co-registrar single complex CSLC, this is our basic ingredients to subsequent higher level products, level 3 product like surface displacement and level 4 vertical land motion. So by North America geographical coverage, we means US states, as well as a portion of Canada, 200 kilometers from US border, Central America, as well as the well-known Cascadia subduction zone. Production will remain until at least 2029 in order to support the production of surface displacement as well as VLM. So in our internal validation, we confirm that the absolute location area for CSLC in terms of a range offset and azimuth offset is below 1.5 meter based on time series examination. So that shows the accuracy aspect of this product. And this product makes it very easy to form interferogram as well as a coherence map, because all the CSLC granules are geocoded on the common grid. So user can just do a simple conjugate multiplication to do interferogram. Surface displacement. So this would, I would say, from our perspective, the most important development milestone last year. So this is so we just finished the historical production of the surface displacement product from 2016 to 2024. The year of 2025 and forward mode are still in progress. So production will continue until at least 2029, just to provide data continuity and confidence to the community who are going to adopt this product into their application workflow. This one will also incorporate Sentinel-1A, 1B already, and currently Sentinel-1C, and in the future Sentinel-1D. And as soon as we receive validated product data from NISAR, the development of NISAR-based surface displacement will begin shortly. So that product will be based on NISAR GSLC geocoded single look complex product as the input ingredient for the surface displacement based on NISAR. It is also the first INGV product certified to have met the CIOS ALD international compliance standard. And of course, as Wei also mentioned, it is a labor of love between Opera and ASF to have developed this visualization portal shown on the right-hand side of the slide. So it provides a very convenient user interface, a point and click interface for user to go into a particular region, click and look at the corresponding time series. So this is just maybe I could just show. Yeah, maybe I just go back. So this one, the visualization portal shows the short wavelength version of the displacement. Short wavelength means anything below 30 kilometers. But the full product, short wavelength and long wavelength, are all encapsulated into the actual product granules. So no information is lost. But as a caveat, when user goes to ASF visualization portal, what they see is the short wavelength version of the product. So shown here is a Mount Edge clump in Alaska. It is a mountain that has been dormant for 800 years, and then all of a sudden in 2028 start to show some surface activities as shown in the time series at the bottom of this slide. And this is another example that we use the surface displacement portal to extract the time series of an agricultural region in Arizona. So all these affect the production of the historical surface displacement data, the development of the visualization portal, as well as these open GitHub tools makes it easier for user to construct the actual times displacement INGV time series, like this one showing the subsidence impact from on this agriculture area. So last line would be the vertical land motion. So I'm going to be quick. So we will produce Sentinel-1 version and NISAR version of vertical land motion products on a 120-meter posting. And it will proceed, the production will proceed in 2 stages. The calibration stage, which is referencing to GNSS, as well as the decomposition of vertical and horizontal components of the line of sight displacement vector. So calibration will go first, and decomposition will come next. The planned release will be in 2029. Production will continue until at least 2029, obviously, to support Sentinel-1 and NISAR version VLM. So I guess we have 3 different cases, use cases that shows the utility of a VLM from groundwater-driven subsidence in California, above ground tank stability assessment in Houston, as well as the urban settlement due to heavy building in New York City, in New York. So yeah, we're very excited that we have a very good we have a lot to offer for years to come from Opera. Yeah, I think that is the end of my presentation. Happy to take any question.
Great, thank you, Steve. And I don't see anything in the Q&A. There is one question that has not been answered. So if somebody wants to take a crack at that one, they're welcome to go for it. Next, we actually have a video presentation from JAXA, since it is about 2 o'clock in the morning in Japan. They sent a video, which I totally understand. So here is that presentation. And hopefully you can all hear the audio associated with this. It's about 3.5 minutes, so it's quick.
Hello everyone. This is KATO from JAXA ALOS project. In this presentation, I will provide an update on the current missions and operational status of ALOS 2 and 4. To begin with, I will introduce the ALOS series. The ALOS series satellites are continuously developed and operated by JAXA, mainly for the purpose of land-ocean monitoring and technological development. ALOS 2 and 4 are L-band SAR satellites, and it has been developed in these series. Mission objectives are to observe disaster damage assessment, land deformation, maritime, and global environment. I will introduce the ALOS-2 mission targets. ALOS-2 has been conducting continuous observation for more than 10 years. From 2025, ALOS-2 and 4 cooperative flights with high temporal or right-left observation in specific area. Since its launch in July 2024, we finished initial functional verification and initial calibration and validation, regular observation based on BOS, and provision of Pulsar 3 standard products started on April 1st, 2025. The distribution of ALOS 2 and 4 data will remain as before, except for ALOS 2 ScanSAR. Data will be provided for a fee through the data distributors, unless it is for RA or bilateral cooperation. I will report on the initial calibration and validation result of Pulsar 3. The figure on the left shows the verification of global mosaic data generation and forest-non-forest map creation in New Zealand. We have confirmed that multiple observations can be seamlessly combined and pre-processed, enabling the successful generation of classification map. The figure on the right shows the evaluation of INSAR analysis result in southern Tibet earthquake. It has been confirmed that interferometric SAR analysis is possible both between ALOS 4 pairs and between ALOS 2 and 4, enabling the detection of cluster deformation. This is a recent observation topic. It has been confirmed that volcanic activity at Mount Kirishima in Japan has intensified. Between last June and July, we observed 3 times using ALOS 2 and 4. The figure on the right shows the animation of the intensity images. We confirmed new features and area that appear to be ejecta around the crater. Currently, there are observations in a fixed PRF mode that suppress azimuth ambiguity and provide image quality consistent with ALOS 2. In this mode, 10 to 20% blind area occur within the observation swath. We published blind maps in KML format on JAXA ERC website. We plan to continue observations with a fixed PRF mode. And finally, Pulsar 3 standard product notification is currently available on our website, and it will be updated as necessary. Thank you very much for your attention.
Okay, great. So that was a quick JAXA update. They do not, they're not here presently. So if you have a question, you could put it in the Q&A and we can try to track down an answer for you. Or you can email it to me and I can pass it on to the JAXA representatives. So next is David Sandwell and Chen. I don't know which of you wants to go first, but go ahead.
I think Anna's going first, yeah.
I will
Okay,
share
great.
the slide and we're going to present together.
Great.
Can people see our slide?
Yes, looks great.
All right. Good morning, everyone. This is Ann Chen. I joined the GMTSAR team in 2023. So today, David and I will give a quick updates on the GMTSAR educational and development activity over the past year that was mainly funded by the NSF Cyber Infrastructure Program. So a few important milestones. So a lot of the ongoing activity for the GMTSAR development is mostly trying to replace some of the seashell wrappers to Python modules. So with a goal to modernize the GMTSAR and also reduce the burden from the user, streamline the processing, and also redesign the processing pipeline so that the code can be faster and easy to use. And beside, we have a web-based searchable GMTSAR documentation. Also, we start to develop a Jupyter notebook for some example case as a way for training materials and documentation. And last year, we also published a GMTSAR textbook that is led by David Sandwell and also built upon many, many years of GMTSAR course material. So this book is available with a hard copy and also available with open access online. I would mention a lot of the radar processing module. While the book documented those algorithms behind the GMTSAR, it can also serve as a general radar reference book for grad students and any people who wants to learn a little more than behind what is going on behind this radar processor. And so as a tradition, we continue to host and develop and maintain the GMTSAR summer short courses. So last year, we successfully hosted a 4-week-long GMTSAR short course with 288 students participated online virtually. And so I want to mention that in this summer, we are committed to continue offer the class, and given that the NISAR was a successful launch, so we aim to start to develop some NISAR-related material. So hopefully trying to promote the use of NISAR data as quickly as possible to the community. So before I handed the talk to for David to talk about the development for the ALOS 4 and the NISAR processor. I also want to highlight one of the things that the original GMTSAR has pretty successfully recruited a younger generation of radar scientists into the GMTSAR community. So here are the the instructors for the GMTSAR course last summer, and many of them are also actively contribute to a lot of this ongoing development effort. So our goal here is, and we are actively also training grad students. So hopefully our goal is to training a new generation of students who can not only work with radar processor as a user, but also can contribute to the development and ready to join the future radar analyst workforce. So David, here it's yours.
Okay, thanks, Ann. Yeah, first of all, it's really wonderful to see all the results coming from NISAR and Sentinel C and D and ALOS 2 and 4. This is a wonderful time to do interferometry. And I just have one slide here to say that we're developing processing workflows for NISAR, the AMD frequencies, and it's really actually quite easy to use these data. They come as HDF5 files, and the data all seem to be easy to parse out the parameters. And so we have a processing chain on the GitHub, and you can try it out when the data become available. And that's it. Thank you.
Great. Thank you, David. The last presentation before EarthScope presentation is from Stefano, Salvi, talking about Geohazard Supersites. Go ahead, Stefano, if you can.
Yeah, sure. Thanks.
And while we're waiting, I'm
You
just
see
going to
my
say for the
presentation here?
should be there hopefully in a second. Yep, there I see it. It's just we need to put it in presentation mode. Yeah.
Okay. Thank you, Chris. Good evening from Rome. Okay, just a brief update on the Geohazard Supersite initiative. We have established a new supersite in 2025 on the Cyprus island. It's a seismic supersite. And so today we have 13 supersites at the Natural Laboratory, which is the San Andreas Fault NL. This is the area of the Cyprus supersite, which is actually adjacent to the Kahraman-Maraş event supersite from the Turkey-Syria earthquake in 23, and close also to the Marmara supersite. And as you know, it's a very high seismic hazard area. We're starting to acquire Cosmos Skymet and SALCOM data on this supersite very soon. A few words on data distribution. EarthScope has proposed to have supersite data distributed through SARA. A few agencies have agreed, so we are now in the process of actually establishing this connection. From historical data from ERS and MVSAT. It's a lot of data, and we are presently looking to find a data storage for these 150 terabyte, because ESA probably cannot host all these data for us. So if you want to support this, please contact me. We are under discussion with research infrastructure in Europe, EPOS, to support European super satellite data. Satellite data for European supersites and possibly also African supersites. But at the moment, you can only get supersite data by contacting the single agencies through the supersite coordinators of the different supersites. Cosmos Skymed and Hakom data are still acquired over the Turkey-Syria event supersite. Please, it's a lot of data, several hundreds, over probably few thousands of images, and contact the supersite coordinators to use this data, have this data and use them, please. Also, there is limited use of SAR and optical images, which are available also for the San Andreas Fault Natural Laboratory. I want to remember you that this data can be acquired, actually, not you can have your site acquired for different research topics, not just for seismic investigations or any kind of investigation linked to the seismic cycle, but also for more broad topics like landslides, soil liquefaction, structural vulnerability, and so on. So please try to use this data. And of course, in this case, we have SAOCOM also and Cosmos Skymed and optical very high resolution from Pleiades. Then the other important topic is the restructuring of GSNL. It's been a long time since we had a new, let's say, a review process, internal review process. And this year, I will leave the chair position. We will have a new chair, and we are going to do this during the EGU in Vienna in May. We have a community meeting hosted by the UN and Office for Outer Space Affairs very close to the EGU venue. So if you are in Vienna at that time, please come to our meeting. And we have to address a number of challenges, especially linked to the possibility for supersites to distribute their data, and also to be able to involve new space companies in supporting the supersite initiative. At the moment, we have, in principle, discussions with ISI to support some supersite with free data, but we want to expand this and contact other companies, commercial companies too. That's it for me. If you have any questions, you can ask through the Q&A. And please write to this email to be entered in our mailing list and be informed about this community building again. Thank you.
Great, thank you, Stefano. That's a great update. So now, actually, we have a small block of time to put either Bex Bendick or Eric Lindsey on the spot if they want to say anything. Bex is CEO of the EarthScope Consortium, and Eric is a formerly WinSAR Executive Committee Chair and now is recently elected to the Board of Directors. So I don't know, you both are in a Board of Directors meeting for the EarthScope Consortium in Washington, D.C., and so stepped out to join us for a little bit. So I don't know if Bex, you want to say anything before we go to the last presentation.
I'll quickly say something and Eric might as well. So first of all, sorry for stepping in midstream in this presentation. I'm looking forward to catching up on the roughly half of the presentations that I missed. But we're at EarthScope are incredibly excited and proud and thrilled and all the good things about the National Science Foundation's award of the operations of the National Geophysical Facility to EarthScope. So we'll be the operator of that facility through 2030. And as part of the vision for a very multidisciplinary and highly integrative National Geophysical Facility, we've moved geodetic imaging from a sort of side-ish activity of the consortium and the major facility squarely into the core of the National Geophysical Facility. So we're super committed to making sure that geodetic imaging is a core part of the integrated geophysics facility capabilities and support. And we not only want to foster sort of technical products and services, but also do whatever we can to keep this community well connected and lively and vital and all things fantastic that you already are. So with that, I will say, like, apologies that this meeting is virtual. The US government has sort of changed pretty dramatically the rules for hosting in-person events, but our goal is for the winter of 2026 to actually return this meeting to being an in-person meeting. We'll just have to be a little bit creative with how we provide, particularly weirdly, the like food and beverage for that. But we have good ideas, and we absolutely recognize two important things. One is that being in a room together with each other in person is really a key part of pushing forward the scientific innovation by collaborating, and also that geodetic imaging writ large is a core part of how human beings explore and understand this incredibly dynamic planet. And so it's our intention to continue to support those capabilities in whatever way we possibly can under the NSF's NGF facility and maybe ancillary activities as well. So thanks for doing all that you do. Thanks for sharing your amazing work and continuing to make this space really vital and innovative. And hopefully I will see y'all in person in December of this year.
Thanks, Bex. Eric, do you want to say anything?
Sure. Yeah. I mean, second everything that Beck said, and I was just going to add that from the sort of the community engagement perspective, I guess I sort of served as the liaison between, formerly WinSAR and now EarthScope, and the community and sort of organizing these meetings. Moving onto the board now, I'm no longer on the advisory committee that I served on previously, so there's sort of an opening there that needs to be filled. And then generally, I just want to encourage everybody in this community to participate in that sort of community interaction with the National Geophysical Facility and with EarthScope. So, there's nominations. You can self-nominate, or you can nominate other people who you think might be great. So, the Data Products and Services Committee is looking for a new member to replace me. So Angie Moore is the chair of that committee currently. So you can look her up or find on the EarthScope website about how to nominate people for that. So just encourage people to be engaged and send Chris or send me or anybody sort of feedback and ideas and thoughts anytime you want. So hopefully we're doing a good job providing the services that the community needs. But if there's anything we're missing or could do better, let us know.
Great. Thank you, Eric. And Bex. And so the last presentation here is an update from EarthScope, from myself and from Kang, who's been doing a lot of the real work here about things we've been working on. So we will do a quick set of slides here. And then again, there's still some open questions and some conversation going on in the Q&A, so feel free to put things there and we will get to those. So here is this. So this is a quick update, as I said, by myself and from Kang about things that have been going on at EarthScope with regard to supporting the geodetic imaging community. So as a reminder, the geodetic imaging activities within the EarthScope consortium, now supported by the National Geophysical Facility, include some things that you've already heard about during this set of presentations. So we have a long history of doing INSAR short courses, both the INSAR Processing and Theory of the GMTSAR course that David and Ann were talking about, and also an ICE related course that is taught every year. And those will happen again this year with a lot of leadership and training expertise provided by many of the people who have presented on this in this presentation and others in the community. We've already talked about this annual luncheon, which this year is this meeting, but the potential to bring back an in-person event at AGU will hopefully continue. And then some of the kind of more operational things are this longstanding support for download, storage, and sharing of PI-restricted data sets from ALOS 2, TerraSAR-X, Cosmos SkyMed, and now we also support PAWS. And I'll talk a little bit more about that in a second. We also have this tool that was developed now over a dozen years ago called the Seamless SAR Archive tool, which provides federated search and access to SAR and INSAR data products at both ASF and EarthScope. And Kang has done a lot of work on this in the last year or so. So I'll show a couple screen captures of that. And then the last thing is an INSAR product archive for publication, sort of fair, compliant publication of INSAR, pairwise, and time series products, which is also something that's pretty new and Kang has been working hard on. So Kang will tell you more about that at the very end of this presentation. Eric mentioned this, so I won't dwell on it, but just to say that, you know, in 2023, with the formation of the EarthScope Consortium, the merger of UNAVCO and IRIS, WinSAR was dissolved as an entity to try to normalize and flatten the governance structure. And so we have this Data Products and Services Advisory Committee, which is the screen capture from the current DPSAC. Eric was the member here, was the sort of SAR representative on this committee until just recently being elected to the board of directors. And so, as Eric said, we're looking for somebody new. I think the nomination cycle for this is May 1st. So if you're interested in serving on this committee and helping support this aspect of data services within EarthScope, please reach out. So one of the things that we do is this PI data set management. And so this is, you know, access to many of these data sets, specifically ALOS 2, TerraSAR-X, Cosmos SkyMed, and PAWS is oftentimes via proposals written by groups of PIs to get access to a data set via an allocation of scenes. And so one of the things EarthScope's been doing for many years is providing the ability for the community to sort of use the EarthScope platform to share and make access to these data sets easier. And so this is just a reminder, mostly for those of you, that there are quite a few of these PI-based collections that are available. If you go to the winsar.unavco.org, the portal, you can log in and see the list of proposals that are available. If you have your own proposals, you can register those by going to your proposals in the upper right, and then entering some basic information from the space agency. And this includes the proposal identifier and how you would log into the FTP site to get the data. Register that here, and then we will nightly check and pick up new data sets and register these into our archive and make them available. And so this is specifically quite powerful because in turn, specific groups don't have to manage the data themselves. We take care of it for you. And so we've been doing this for quite a while. This is just a quick summary of the available data in the archive. This is 183 terabytes of SAR data. So this is like less than 3 days of NISAR. This is not a particularly large data collection in totality, but serves a specific niche within the community. And so in the plot in the upper right there, data volume over time, ALOS 2 is the big primary contributor here. We're managing a fair amount of ALOS 2 data specifically for these PI scenes. The bottom two panels are the kind of spatial catalogs of data available from EarthScope in particular. On the left includes the sort of legacy ERS1, ERS2, and MVSAT data and RadarSat data sets that go back to kind of the very early WinSAR and EarthScope project collections. And then on the right is just the PI data sets. So the TerraSAR-X, ALOS 2, Cosmos SkyMed primarily that are available. Seamless SAR Archive. This is a tool that, as I said, is over a dozen years old. Was initially built with NASA Rose's funding in collaboration with ASF. But Kang in the last year or so has entirely rebuilt this from the ground up, and I think it's in the user experience is improved. It's more intuitive, it's more feature rich, and so I just want to remind you all that this exists both as a GUI search tool, which is what the screen capture here shows, as well as a command line interface. So for those of you who want to programmatically be able to download data, the CLI exists as well. You can do searches by kind of basic spatial selection like boxes, polygons, point and radius searches. Some of these features were requested by various members of the community. And then filter that search by satellite collection, date ranges, and then various other SAR parameters. And so if you've used this in the past, it is similar functionality, but as I said, again, much improved in terms of usability and performance and things like that. The other thing that Kang's done, which is kind of cool, is if you, in this upper right, once you do a search, you can export a SAR script. So this is basically pre-generating the Python script necessary to use the CLI to automate data downloads. And so this is something, if you haven't used the CLI before, you can use this to sort of teach yourself how to build those Python scripts. And then the last thing to talk about, I'm going to toss to Kang here. Kang, you can take over. Is this INSAR product archive work that is quite new, and as another feature that has been requested by the community in recent kind of white papers about the future of geodetic imaging at EarthScope. So Kang, do you want to say the last few words?
Yeah, so I'll just use the screen share you are having on
Great.
here. So building on what we have just heard about the exciting updates from the SAR missions and the software updates from the groups, I'm going to give a quick overview of the INSAR product archive that we at EarthScope has been working on. Our goal is to support the FHIR compliant archiving so products can be findable, accessible, interoperable, and reusable. As some of you may know, we have developed a legacy HD5 format quite some time ago for INSAR products, but it was not widely adopted. One major reason was that it was designed primarily to store a single interferogram for each file. So the approach was useful and important at the time, but it doesn't align well with the modern SAR missions which generates regular and more frequent acquisitions. As a result, the community is increasingly focused on high-level products like velocity and temperature analysis rather than single interferograms. So with that in mind, our new HD5 products data model now are designed to support multi-track and multi-platform data sites, and can also archive data from different processing levels. And finally, our new system integrates the DOI request module, so you can request a DOI so that the data you upload can be persistently cited and tracked. And next. So this is a kind of a quick overview of the new format specification for the INSAR product. We have put together a detailed documentation webpage for this new format. The key update in this new format is that we now support, again, multiple tracks and multiple platforms, as well as multiple data products, instead of just a single interferogram per file. On the right, you see the HD5 hierarchy from an example data site. The file is organized by track, and within each track, the data sites are grouped by product types, including interferogram, temperatures, and velocity. Again, the full specification can be found at the link on the bottom of the page. Next page. Next slide. So this slide basically shows how you can upload the data to the system. So in the geodetic imaging data portal, you can, under the data tab, there's a INSAR product archive option. Click on that will lead you to the introduction page where user can browse the data sets that have been already uploaded, and on the interface to upload the new products. And once the upload is complete, the data will appear in a user dataset list along with the key details such as the mission track, dates, and product types included. And finally, I want to emphasize that the INGV products archive is fully integrated with SAR search that Chris just showed. So when people can use the same interface to search the existing INGV products that have been archived to the system. And we are still working on this, but if you have any questions or feedback, please email geodeticimaging@earthscope.org. That's it. Thank you.
Great. And that's the last slide from EarthScope on the presentation. So thank you, Kang. Yeah, this work in particular, the INGV product archive, as I said, is something that people have expressed some interest in having a place to share these kinds of products. And Kang's been doing a lot of work on this in the last several months to build this out. So definitely we encourage people to give it a try. And if you have feedback, please do send that along because we really want to make this something that serves everybody's needs. So I think that's basically it. As we always do at these things, we have a tendency to use the available time allocated. So it is we're only a few minutes from the bottom of the hour. We had allocated 90 minutes to this webinar. So I don't see any other questions. There were quite a few good ones answered by folks over the course of the last 90 minutes. If anybody has any final questions, feel free to toss them in. But I think this concludes the meeting. So thank you all for coming, specifically to our presenters who took the time, sometimes at weird hours, to be available for this. And we will record. This has been a recorded video, so we will get this cleaned up and posted and made available to everybody. Thank you all again and stay tuned. We will, as Beck said, try to see if we can bring this back as an in-person event next year. So we'll keep it posted. Thank you all.
Thank you.
Thanks, Chris.
Thank you, everyone.
All right.
Thank you.
Thank you.
Bye-bye.
Thank you, Chris.
All right. Thank you all.
Thanks, everyone.